So my friends, what is finite element analysis? So in this video, we're gonna learn about the brief definition of finite element analysis as a methodology, as even a mathematical approach, and even the methodologies which are used with the even assistance of the calculus of variations. Hi, by the way, my name is Chintamani, and I'm your friend, and I'm your fellow aerospace engineer, and by the way, I'm aspiring gynecologist. So my friends, in this so-called channel, I gotta give you, some of the updates, guys, about the real engineering world. And in this video, guys, we're gonna talk about the finite element analysis. So, my friends, as I already explained to you, guys, finite element analysis is basically a methodology, guys, with methodology in which we basically use the differential equations, guys, to solve one particular problem. So, guys, it's a methodology, where you, in fact, while you gotta solve a problem, guys, you gotta use partial differential equations, guys, to be more precise, guys. And the finite element analysis, guys, is really helpful, guys, to solve the problems of electromagnetic potential, workflow, heat and mass transfer, and even the structural analysis, guys. And basically, guys, what finite element analysis means is, guys, it's basically an algorithm, guys, developed in 1940s, guys, to study a so-called object, guys, part by part, guys, by basically meshing that so-called object. So, guys, if you gotta study anything, guys, maybe in vehicular accidental management, or maybe the risk assessment for the aircraft's crash, or rather the air crash risk assessment and stuff, guys. In those are crucial areas, guys. With the finite element analysis, or rather the methodology of finite element, which is also known as the finite element method, guys, is used, and it is popularly used, guys, to perform those computerized three-dimensional computerized simulations, guys, of real engineering operations, guys, like maybe on work in an oil reservoir, or rather, maybe an car crash, or rather, maybe an aircraft's disaster management and stuff. So, guys, what finite element analysis, helps you to do is, guys, it basically, helps you to create three-dimensional computerized simulations, guys, of all those engineering eventualities, guys, and the way in which, it happens in real life, guys. Maybe the damage, caused to a propeller, guys, by the striking of a bird, or maybe the way in which, a ship like Titanic, guys, after hitting an iceberg, guys, like what took place on April the 14th, 1912, like what happened, guys, over there, with Titanic, after it hit the iceberg, the way in which the fuselage, or rather the way in which the entire body, the way in which, the lower back section of that Titanic ship, guys, after accidentally, colliding, with that so-called iceberg, the way in which, it broke, guys, those are real eventualities, guys, can be very well understood, guys, and even mathematically even modeled, guys, with the aid of assistance and even with the implementability of the finite element analysis. So, guys, what finite element analysis does is that basically, it breaks a problem, guys, into smaller and smaller elements, guys, it basically, divides a problem, into smaller elements, guys, which is even very well known as meshing, guys. And it performs it in multiple variables, guys, and there happen to be multiple approaches, guys, while we got to study and finite element analysis of a particular object, or maybe a real-time engineering eventuality. And there seem to be two really popular approaches, guys, and number one, which was in collaboration between the scientists Raleigh and Mr. Ritz. So the Raleigh-Ritz methodology and even the Galerkin's approach, guys, happen to be two of the fundamental approaches, guys, which are used, guys, while we study the boundary level problems, guys, in multiple variables. And, guys, what meshing really means is, guys, that and so-called object, guys, while it's equally divided, or while it's equally separated, guys, not in reality, guys, but just for the purpose of mathematical modeling, guys, what it's done, guys, that is known as meshing, and which is even popularly known as the conceptualization of the discretization. So guys, what discretization does is that, guys, you know, I mean, if you gotta study something like maybe uh, maybe a geometrical figure like this and stuff, you know, I mean, maybe a cuboid or maybe even a rectangular and stuff. Guys, number what finite element analysis number does for you is, guys, number finite element analysis, guys, number the inner systems of this discretization, guys, you know, can basically, you know, offer dividing this so-called box, or rather, you know, anything, you know, a piece of cobalt, or rather, and geometrical structure, guys, which you got to study, guys, you know, maybe an aircraft, or maybe a train crash, or maybe the bird strike accidental analysis, guys, you know, which needs to be performed, guys, you know, by the aerospace engineers, you know, in the industry. So what finite element analysis does is, guys, that finite element analysis basically, you know, gives you one greater work tool. Finite element analysis, you know, serves to be like a greater work tool, guys, you know, which actually, you know, helps you to study that problem, guys, you know, exactly the way in which, you know, it would have taken place in real life. And, you know, it is really cost efficient, guys, you know, because it is simply not at all possible, guys, you know, to study aircraft crash, or rather than aircraft calamity, or rather disaster management, guys, you know, with a real aircraft, or rather, you know, which is basically not even used as an unmanned aerial vehicle, guys, and to perform that test, guys, you know. You basically, you know, got to compromise that entire aircraft, guys, and simply, you know, for the purpose of that testing. But, guys, you know, what finite element analysis does is that finite element analysis basically, you know, breaks down that so-called problems, guys, you know, and it creates a lot through the inner systems of meshing. And, guys, you know, that so-called eventuality, guys, of an crash, or of an air crash of an aeroplane, or rather an aircraft, guys, or rather the disaster management, you know, which is basically, you know, required to be performed, guys, of an air crash, or rather an calamity, you know, which basically, you know, takes place, you know, while an aircraft is airborne. You know, those all things, guys, you know, can be very well studied and analyzed, you know, with great precision, guys, you know, through the applicability of a three-dimensional computerized simulation of the entire problem, guys, you know, and the entire eventuality, guys, you know, in the real engineering world, a number which is really accurate. And you can often, you know, call it as like the synthesizer, guys. Like, you know, you do not, in fact, you know, got to test all the musical instruments, or rather the equipments, maybe whichever, percussion, drum, or maybe the digitalized, or maybe the electronic, or harmony, piano, whatever. Synthesizer, what synthesizer does for you, the same thing, you know, I mean, is performed by the tool, finite element analysis. And basically, guys, you know, finite element analysis, you know, in its entirety, you know, was not developed, you know, by a single mathematician. You know, basically the Professor A.R. Clough from the United States, guys, you know, who is basically a structural engineer, guys, you know. He was, you know, he is widely known as, you know, and he basically had that expediency, guys, you know, to institutionalize and conceptualization, guys, you know, back in the times of World War II, guys, you know, back in 1930s, you know, basically pre-World War II, you know, I mean, to come up with this so-called conceptualization of finite element analysis. And, guys, you know, basically the differentiation, you know, between the finite element analysis and finite element methodology or method is that, guys, you know, I mean, the finite element analysis is the actual methodology, you know, with the inner systems of which, you know, I mean, the structural heat flow, or rather the heat and mass transfer, or rather the electromagnetic, the problems, guys, you know, from the world of electromagnetism, guys, you know, are basically studied. So, guys, you know, that finite element methodology, you know, it just seems to be like in modus operandi, or rather than core of algorithms, guys, you know, which is basically going to be used to tackle those mathematical problems, guys. And what the finite element analysis means is that is the actual analytics, guys, you know, which we basically, you know, perform, you know, with the inner systems of greater softwares, guys, you know, some specialized softwares like even TensorFlow, guys, in order to study as, you know, what basically, you know, happens in that eventuality, guys. So finite element analysis, guys, you know, can really, you know, help you in that domain. And finite element analysis, guys, you know, has gotten a great option, guys, of studying a particular problem, guys, you know, through the in multiple variables. Like basically, you know, after the discretization, you know, is performed, guys, you know, each and every element, or rather each and every part, you know, which is basically, you know, divided on that entire object, or rather that entire eventuality or whatever it is, guys, and it's basically under an assignation of a coordinate, guys, which is basically known to represent that element, guys, and which is in turn used, guys, for the mathematical analysis, guys, of those problems. So finite element analysis is, guys, really a theoretically ultramodern engineering tool, guys, and used by scientists and engineers, guys, in the industry, guys, to basically study, to basically apply their techniques of visualization, and guys, even for the purpose of engineering optimization, guys. And it's a great industrial tool, guys, which is used nowadays, and you can basically explore whatever you want with it, like basically whichever problems you gotta deal with. Like how I gave you the example of the Titanic ship, guys, the way in which, after hitting that iceberg, guys, how it met its deleteriously cataclysmic end, or, how it actually, sank, guys, on the night of April the 14th, 1912. Basically, how that took place, guys, you can basically, analyze it in a great precision, guys, with the inner assistance of the finite element analysis. So what finite element analysis really means is, guys, that you can basically, study a real scenario, guys, which basically, will require a lot of cost and a lot of economy, or rather, a lot of equipment, so a lot of, basically, a lot of resources, guys, to perform those really rigorous and really dangerous and really absolutely hazardous tests, guys, in industries. Basically, guys, when it even comes about an atomic explosion, guys, or rather, the damage, which is caused by an atomic bomb and stuff, guys, can also be in detail, guys, analyzed, with the aid and assistance of the finite element method. And which is why, guys, the finite element method, is really a cost-efficient methodology, guys, to study those problems, guys, study the problems, in real engineering. And as I've already told you, guys, the discretization, guys, basically, seems to be one of the most fundamental methodologies, guys, used, guys, under that set of algorithms, guys, developed by the set of algorithms, or rather, which are not exactly the algorithms, guys, those are basically just the standard operating instructions, guys, which are used. And the partial differential equations, guys, are basically used to analyze it. And which is why, guys, what finite element analysis really means is, guys, is a way of, solving the engineering problems, or rather, way of analyzing the particles, or rather, analyzing materials, through the applicability, or rather, executability of the partial differential equations, guys, and perform the mathematical modeling or three-dimensional computerized simulation of all those problems, guys. So, for that, finite element analysis is a very well-known industrial standard nowadays. So, guys, for more updates about finite element analysis in its entirety and stuff, please do sign up for my channel, and please do subscribe it. And in case if you like my content, then please do share it, with your friends, or rather with your pedagogic colleagues and stuff, and which will help me, to grow my channel more, and which will even keep me motivated, guys. So see you guys, and have a really great day, and basically sign up for my channel. See you, and bye bye.